Welcome back, everybody. This is the first of two, maybe three videos in Unit 1, Section 7 for AP Calculus, selecting procedures for determining limits. We'll see how it goes. Like I said, I figure it'll take me at least two videos to get through the examples that I have down here. It might take three. So strap in and join the ride. All right. So basically, we've reached the stage where we've learned a number of techniques for finding limits, algebraic, and different things that we can do algebraically. We've also learned how to do them graphically and numerically, although in this lesson, we're really focusing on the algebraic approach and different techniques that we can use and things to look for and how to approach a wide variety of different limit problems. So, tips for how to approach finding limits when you're presented with any type of limit using algebraic techniques. Number one here, I heard this advice and I thought it was great. Keep your pencil moving. Try things. Don't just stare at a problem, because if you look at a problem and you stare at the 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 problem, eventually you'll find that minutes of your life have gone by and you've made no more progress. Try something. Even if that something ends up not working, try something. Then advice number two, keep track of your failed attempts. If you try the problem one way and you find that, it absolutely doesn't work, hopefully keep track of that so that you don't go back and do the exact same thing and try the exact same thing again. If it helps you, list relationships. What type of relationships might help you in the problem? What kinds of things do you see in the problem that can help you? Look for things to quote unquote play with. Are there things that we can simplify? Are there radicals in the expression that we can use conjugates to simplify the limit? Are there pieces of trig that we might be able to use identities to simplify things? Is there some type of factoring that we can use to try to figure out things? And then lastly, the last thing to worry about, if you're dealing with a piecewise function, make sure you're looking at both the left and the right-hand sides as you're trying to find those limits. Okay, so let's look at example one. In example one, what we're going to do is we're going to actually find the limit as x approaches 6 of the quantity x squared minus 36 over the quantity square root of x minus square root of 6 in two different ways. Okay, so the first thing we would try, of course, is we'd try to substitute, and we'd see right away if we substituted 6 in here for x that this is of the form 0 over 0, and so we're dealing with an indeterminate form. Now, when I look at this problem as it's written, I see, some radicals in there, which instantly makes me think, hey, maybe I can handle this by using some kind of, using the conjugate and trying to simplify it that way, and seeing what happens if I use a radical rationalization. I also see in the numerator, I see the quantity x squared minus 36, which is something that I know can factor, and in fact, we're going to talk in this example about a way to factor it beyond what you've probably done in any of your other courses prior to this one. So we're going to handle this two different ways. Let's start with way number one, this radical rationalization. So if we were doing it that way, we would take the original limit here and we would multiply both the numerator and the denominator by the conjugate of the denominator. So we're going to multiply the numerator by square root of x plus square root of 6. And we're going to multiply the denominator by square root of x plus square root of 6. And when we do that, that gives us the limit as x goes to 6 of the quantity x squared minus 36 times the quantity square root of x plus square root of 6. All over. And in the denominator, we would FOIL this out, but the two middle terms, the plus square root of 6 times square root of x and the minus square root of 6 square root of x, would cancel each other out. That's the utility of using the conjugate there. And we would just end up with the expression x minus 6 in our denominator. Now, even though we started this with radical rationalization, we quickly find out when we get to this point that we're going to need to use factoring as well. And we still can factor what's up there in the numerator. We can take that x squared minus 36 and factor it as x plus 6 times x minus 6. And then we see that we have a common factor between the numerator and the denominator. We can cancel out the x minus 6 from both of those. And this just becomes the limit as x approaches 6 of the quantity x plus 6 times the quantity square root of, I got ahead of myself there, square root of x plus square root of 6. And now we're going to find the limit by just substituting, and this becomes quantity 6 plus 6 times quantity square root of 6 plus square root of 6, which is 12 times 2 root 6, or 24 root 6 as our limit. Okay, so that's one way to handle this problem, radical rationalization and simplifying from there. A second way for us to handle this problem, potentially, might be factorization. And so the first thing that I would do if I were going to try and find this limit factoring, I'm going to scroll up a little bit here so I don't have to reach so far, is we're going to factor the numerator, and that factors as x plus 6 times x minus 6 all over square root of x minus square root of 6. Okay, and this is where we're going to do a factorization that many of you probably have never done before. I'm going to take the expression x minus 6, and I'm going to factor it as the difference of two squares. Remember that the quantity a squared minus b squared is equal to a plus b times a minus b. And so what I can do is I can factor any expression that is a binomial with a minus sign using this difference of two squares. And if that's the case here, what we really are saying is we're saying that, we're going to set a squared equal to x and b squared equal to 6. And so a is equal to the square root of x and b is equal to the square root of 6. And looking at it that way, we can use this factoring pattern to factor x minus 6 as the square root of x plus the square root of 6 times the square root of x minus the square root of 6. And that's exactly what I'm going to do in my next step, is I'm going to take that expression and I'm going to factor it that way. And so we've got square root of x plus square root of 6 times square root of x minus square root of 6. And now you should notice that we have a factor in common between the numerator and the denominator. And so we're going to go ahead and cancel those two out. And this limit now becomes the limit as x approaches 6 of the quantity x plus 6 times the quantity square root of x plus square root of 6. And you'll notice, I meant to change color there. You'll notice that this expression right here is the same as this one right here, and so the rest of the work from there on in is going to be exactly the same. In finding this limit, we substitute 6 in. We simplify, and we end up with our same answer, 24 square root of 6. And so what this problem really shows us, there's more than one way that we can handle our approach to a limit problem like this. But notice, I just went in and I kept grinding and grinding and trying to figure things out until I ended up with something that I could simplify. And that's what you should do anytime you are approaching any kind of limit expression that you're trying to simplify. Go ahead and play with it and see what happens. All right. The rest of this lesson just consists of more examples. We'll look at situations and talk about things that can and do happen in these. So let's go ahead and we'll start with part A, the limit as theta approaches pi over 2 of the quantity 1 minus sine squared of theta over cosine of theta. If you know your trig values, the cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So this is 1 minus 1 squared over 0. So guess what? Shouldn't surprise you that this is going to be the indeterminate form 0 over 0. I mentioned a few videos ago that really when limits are the most interesting is when we get an indeterminate form. If we just substitute in and that's the limit, that's sixth, seventh graders can do that in pre-algebra and algebra. It's when we get these indeterminate form problems that things get interesting. So we get 0 over 0, and a lot of times in order to handle 0 over 0, we try to factor something or do something like that. But I don't think that that's really going to help us here with this particular trig-based limit. What else do I know about trigonometry? Let's see. I do know, I'll tell you, for years I didn't remember a lot about trigonometry, but one thing that I think all students remember from trigonometry is that sine squared of theta plus cosine squared of theta is equal to 1. And so this 1 minus sine squared of theta is equal to the quantity cosine squared of theta. So I'm going to go ahead and replace the 1 minus sine squared of theta with a cosine squared of theta. And now I can cancel a cosine of theta from both numerator and denominator. It turns into this limit. And then I can just go ahead and substitute pi over 2 in there. And the cosine of pi over 2 is 0. All right, I'm done with part A of example 2. You know what, let's do one more here. Squeeze it in real quick. The limit as x goes to 1 of square root of x minus 1 over x squared minus 1. This is almost identical to our first example from today's video, just different numbers to work with. And so I have a choice here. I can either approach it by using radical rationalization, or I can factor it. Choice is yours. Again, we're in a situation where if we try to substitute, we end up with 0 over 0, the indeterminate form. I'm going to go ahead and handle this by factoring. If you want to do it by radical rationalization, that's fine. Just make sure that in the end, you and I end up with the same final answer, and that should mean that your process was correct. So first I factor it as quantity x plus 1 times quantity x minus 1, and then I'm going to factor the x minus 1, how we did in part B of example 1. I'm going to factor it as quantity square root of x plus 1 times quantity square root of x minus 1. And now those cancel each other out, and I'm left with the limit as x goes to 1 of 1 over quantity x plus 1 times quantity square root of x minus 1. And I go ahead and substitute, and that's going to be 1 over 1 plus 1. Oops, I canceled the wrong factor. Never mind. Cancel that one instead. So that's an x plus 1. So we've got square root of 1 plus 1. And so this turns into 1 over 2 times 2, looks like. And so we end up with a limit of 1/4. All right, we'll stop there for now in this video, and hopefully you can join me again for the remainder of example 2 in the next video. Look forward to seeing you again. Hope you all have a great rest of your day, and I'll see you next time.